Rowan, I'm on a call. Morning.
Hello.
How are
Good
you?
morning. I'm good. How are you?
I'm okay. um,
You at home this time?
I am at home this time, and you can hear that my 5-year-old is playing Fortnite in the background. So
I see. I see.
I've already warned him to be quiet so we can talk.
Oh, that's fine. That's fine. I can hear you.
Okay, so we'll wait to see if the other Huang joins us, and then there's another guy who missed lab who might join in.
Oh, okay.
So let's.
I will send a message to him.
Yep, no, he's good. The other Huang is joining right now, so.
Oh, okay. Nice.
One thing I'm gonna do while I'm not sharing my screen is I've been trying to download the videos that I took yesterday in the lab so that I can show you guys in video form. I think the video is better. But it
Well,
seems
you can
like,
also upload that.
yes, but they're right now they're on my phone,
Oh, yeah.
streaming over to Amazon Photos, and then I'm going to bring them into YouTube and post them on the Moodle site. I just thought that they would be available right now, and it doesn't seem like they are. So, but maybe if I log out again and log back in. So how has your week been? Okay?
Yeah, it's just the first week.
Yeah.
It's pretty good.
Yeah, good.
The workload is okay, so yeah.
Excellent. Good. I do have to tell you there was an issue with the writing guide assignment. Did you guys run into that trouble?
What do you mean?
What do you mean, like the slide thingy?
Yeah, yeah. Or did you do okay with it?
I did it, but I didn't get the full mark for that, and
Yeah.
I hit redo it, but I couldn't redo it. So
Right,
Yeah.
right. So to give you a little bit of feedback on that, hold on one sec. I'm just trying to sign in and see if that updated for me. So we had Moodle training over the summer, and Moodle installed a whole bunch of new assignment types that we could try out and test out. One of them is this HP5, which is, we thought was pretty cool because you can like make a PowerPoint, but then have like a quiz as you go inside of it. So the idea was that you could, you know, build that in, and then you could go back until you got the answer correct and move forward. So Mark Lesser, so I sort of built a whole lab course Moodle site, and then Mark wanted to try out this assignment, which would take the place of the PowerPoint that I also have posted. Normally in class, we would just be looking at the PowerPoint. I'd be giving you a lab report, and we'd kind of be deconstructing it along the way. And instead of doing it that way, he thought, well, let's just try this H5P. And it looks nice, but moving through it, there's one certain question type. I don't know, remember if it's the multiple choice or the true false or the place it in this order. But when you get it wrong on one of those types, it won't let you go back properly to fix.
It just
So,
stay there.
yeah, but if, as long as you were able to advance through it, through the whole thing, even if you, I mean, because you probably sensed that you got it right, even though it was telling you maybe you got it wrong, and learned the content, then you're fine. And I'm gonna adjust the credits on that because we were just kind of learning it, you know.
Yeah,
So,
I see.
but how about the muskrat assignment? Did that go okay?
Yep.
Okay. All right.
Yeah, the help page is like very
Yeah,
helpful.
it's very detailed actually.
Yeah, I
Yeah.
thought that was good.
Super
Yeah.
detailed.
Yeah. Okay, so I think we should be good to see this stuff, which is great. So give me one sec. All right. So then no questions, I guess, on that first lab experience, right? Like the writing and the stats, you guys are feeling pretty confident about it?
I guess so.
Yeah. Are both Huangs on here? Because I'm only seeing one.
Yeah, I can see the other one.
Oh, you can see the other one? Can he hear me?
Yeah.
Yeah, I can hear you.
Okay, all right, there we go. All right, so you guys are just switching back and forth visually. So again,
Yeah.
another guy might jump in on our Zoom. I'm hoping he does because he's been kind of absent the last couple days. And as long as you're feeling good about science writing, again, if it wasn't super clear with that H5P, there is a PowerPoint in that section that shows the same content pretty much as that H5P. So you could always go back to that. It was important for us to give you guys that exposure early on because the first assignment that we tackle with this lab, the optimal foraging lab, is to start writing your rough draft of the lab report. And so you'll begin with just the introduction section and just the methods section. And it's kind of an early leap because we haven't really, you know, talked about the content of the introduction, like the background stuff yet. I'm going to give you a little overview of that today. And I'm not sure how familiar, you guys have done lab reports, right? Before?
Yep.
Yeah.
A lot.
Okay. So you've done research on Google Scholar, you've found articles, you've paraphrased them and did the internal citations at the end in parentheses. You might have done footnotes or something, but we usually do something with a parenthesis at the end with author's last name, comma, year.
Oh. Okay.
And that's just the Council for Science Editors formatting style, CSE. I don't know if you're not familiar with it, it just basically takes your footnote and makes it like author's last name, comma, year. And I believe at the bottom right-hand corner of our Moodle site, I changed, there's like a spot in that lower right-hand corner that tells you like citation style.
Oh, I see.
And I have it there, so in case you're not sure, you could click on that and it'll bring you, I think, to a page that shows you that. But our writing guide in the manual gives you some examples of that formatting style.
Okay.
But really, we frown upon quoting And we would much rather have you paraphrase the content and then just make sure you've got those internal citations. So again, yeah, introduction on optimal foraging. And I'm going to send out an email to like the whole group. You guys have been getting my emails, even though you're not needing to attend face-to-face, right?
Yes.
Okay.
Yeah.
Yep.
Every week.
Great. Yeah, I'm kind of crazy about them because, but I just want to make sure everybody is hearing what I'm thinking. So, you know, when we approach optimal foraging, you know, we think of it maybe from the perspective of a squirrel or a fox, right?
Yeah.
Some animal that needs to, and humans too, right? That needs to acquire energy. And obviously, like, we want to be efficient about it, right? We don't want to have to like hike miles to find enough food because it's going to counterbalance the energy that it took to get there. So you kind of adapt by thinking about the surroundings around you. Maybe you have predators around you, or maybe you go into an area that has a lot of competitors around you, and you change your behavior a little bit to reduce the amount of energy that you need to expend in order to get the food. So you might actually even change your food choice when you're surrounded by these other, you know, organisms that could impact your behavior on feeding, right? So you can imagine if you had, if you went into an area that was all fenced in and you were like a squirrel and there were no foxes that could get into the fence, then you might eat like anything you want and take your time and you don't have to look around you. But if you needed to be cautious, right? And maybe, and there was no fence around you and you might need to go out at night or go out during the day whenever the predator wasn't active, or you, you know, might choose food that's just nearby hiding cover instead of going out into the open to eat the good stuff. And so you know, you make these adjustments, and the same is true. Those are biotic factors. So like living organisms that change your behavior. When we talk about feeding behaviors. But there's also, you know, non-living or abiotic factors that can impact how you feed. So imagine like a snowstorm hits, right? And you've got really deep snow and you're a moose or you're a deer and you're trying to get through the snow, but it's like up to your waist. It's really hard to move to get to the food. And so you could starve to death being stuck out in the middle of the open. So cold weather, you know, temperatures, rain, cold rain, snow. Actually, there are some that do really well with deep snow that has a strong crust on it. You know, that's kind of why we use snowshoes, right? So we can not sink down. But there's animals out there like wolves that have giant, and caribou too, they've got like giant paws. So it kind of gives you more surface area to spread out the weight, and you can actually kind of run, not that a caribou is running across the crust, but a wolf can kind of glide across the crust of snow and is really effective as a predator in the wintertime. So there's biotic and there's abiotic factors that alter how organisms feed. And every organism, again, is trying to forage optimally. And so your introduction section, as you guys write your draft, and I'm going to send an email out, but also at the end of our section for the optimal foraging is the rubric or the checklist for what needs to be in the lab report. So you can kind of cross-check. You always want your introduction, and you learn this from that H5P, to be broad, right? Broad at the start, and then taper down to your hypothesis. And so I can imagine you guys would probably start off by just saying, what is optimal foraging theory, right? So go on to Google Scholar, find the first people that coined the term. I think it's like MacArthur and Pianka, Robert MacArthur and Pianka.
It's like very long ago.
Yeah, like in the 60s, I think.
Can you repeat the name of that?
Yeah, it may
scientist?
actually even be in our lab manual, in the introduction section of the lab manual for this exercise. MacArthur, M-A-C, A-R-T-H-U-R.
Yeah, T-H-U-R, okay.
And Pianka, P-I-A-N-K-A. I want to say it was in the 60s. But MacArthur is like, he is really a prolific ecologist. He was active in doing the island biogeography and looking at biodiversity in islands based on the size of the island and how far away they are. So a lot of the foundational concepts of ecology, MacArthur had his hands on. Smart guy. I actually taught his granddaughter when I was at Penn State. It was pretty
Oh, nice.
like, you are a movie star. And he died young, unfortunately. So we were robbed of his, knowledge. Just a brilliant guy. He actually spent a lot of time. I think Dr. Aldred's going to talk about it. I always talk about it. But when you get into competition, sorry, my kids screaming in the background. When you get into competition, he did his PhD work maybe, or his master's work in the conifer or like evergreen forests of New Hampshire. And there's this species of warbler, these tiny little birds. There's actually many species of warblers. They all like to eat these conifer seeds, these, like the pine seeds and stuff. And he wondered, how can these forests support like 15 different species of warblers that all like the same food? And what he found when he went up there and just sat and listened and watched is that they partition the Christmas tree into different areas, right? So some will only feed at the top, some will feed at the bottom, some feed close to the tree trunk, some only feed in the periphery. And so there's zonation. They kind of zone out. So they don't,
like territory.
Exactly. Exactly. So they don't compete with each other as much if they can like partition it. And then they also add in like a different kind of feeding behavior. Some will like dive bomb, some will flutter and hover. And so it's kind of interesting to read that article. But anyway, so talking broadly in your introduction of the rough draft about what optimal foraging theory is, throwing in the words, and again, if you go to the, that you've heard this probably if you read that optimal foraging manual section, specialist versus generalist organisms, right? So if you're a specialist, you're going to always eat a certain type of food that you love. Like I love samosas and chicken tikka masala, right? I don't know if you guys like Indian food, but it's my favorite. And so I might want to specialize on just eating that. It's going to give me just the right amount of energy. It's going to make me content. But I might have to go a long distance. We don't have an Indian restaurant in Plattsburgh. I might have to go to Burlington in order to get it. Okay. But when I get it, I'm going to have exactly what I need. So if you're a specialist, you might have to travel far, but your handling time, once you get it, because that's what you love to eat, how to process it well, is fast. And your search time is going to be low because you know what it looks like because you feed on it all the time, right? So imagine you're a wolf on the landscape and you like to eat moose. Well, if you've seen one moose, it's easier for you to spot other moose as opposed to somebody new to the area, right? So a specialist is really good at getting efficient and optimally foraging if they reduce their search time and reduce their handling time, right? They're really good at it. They're efficient because that's all that they ever are eating. Rowan, why don't you come and eat your food, Rowan? It's right over here. Okay, I'm on a Zoom. I am on a Zoom. I'm sorry, you guys. They're 9 and 5. We'll do what we can. They're fighting over Fortnite right now. Hold on, I'm gonna put you on mute for a sec while I go mom for one moment.
Please, go ahead.
Okay.
Playing tail game.
Nice.
All right, so I'm back, sorry. Okay, so if you are a generalist, you're gonna do a different strategy. And that strategy is gonna be, I'm gonna just eat whatever is close to me and maybe eat large quantities, and whatever it is, that's fine, I'll just deal with it. In doing that, you're not reducing your search time. Well, you are reducing your search time because you're taking whatever is next to you, right?
Yeah.
And you're reducing your travel time because you're not going to have to go seek it out far distances, right? And so again, just kind of tinkering with travel time, search time, and handling time, and approaching it from a specialist versus a generalist strategy. And you can change your strategy depending on what happens around you, right? If it snows, maybe you go from being a specialist to a generalist. So, right, in certain seasons, you might, like in springtime, wolves might be specialists, but in wintertime, they might switch over to being generalists because they're going to just take what they can get. If that makes sense to you guys, right? So abiotic and biotic factors are going to alter how organisms forage. And again, an organism is just trying to forage by getting the most energy, maximizing energy, and doing it the most efficient way. So they don't have to expend a lot of energy to do it. Okay. So broadly, your intro is going to start with the background stuff like that. And then it's going to move down to biotic factors. And then it'll move down to abiotic factors influencing foraging. So you'll have like a paragraph for each of those. So what I would encourage you guys to do, and maybe I'll share screen right now, and let me just pull it up. Hold on one sec. Is right here. Okay, can you guys see the Moodle site?
Yep.
Okay.
Yep.
So the optimal foraging under the abiotic and biotic stressors, it's going to talk a little bit about what we just covered. It's going to suggest, here's the lab manual reading, which I handed out. This is the draft. This is like a Dropbox for the sections. You're only going to be doing this one for next time, right? And that's where your lab report will go for the final one. But the overview page will give you, here's the MacArthur and Pianka article I mentioned, right? You can click on that. And it talks about the biotic and abiotic factors, specialists and generalists. This is the overview to give you a sense of what's going on in the lab. Then we're going to do next week, we're going to just Zoom. So what I'll do for you guys is I'm going to run the class on Wednesday just in a Zoom format, and I'll just share that Zoom up in our area where I've been saving our recordings. We don't actually maybe need to meet unless you have a concern. We might not need to meet. You could just watch that Zoom of me going through the lab data analysis. And then you guys could touch base with me if that works for you. You could touch base with me if you had any troubles with it. I'll post the data. I'll probably email it to you guys as well. And then you can kind of play around with it. And if you run into trouble, you'll let me know. But it'll be kind of like that data analysis screenshotting thing that you'll see me actually in the Excel doing it for you, okay? And hopefully other students doing it with me. And so we'll get into a little bit of chi-square. This optimal foraging raw data of 2019, I'll replace it with ours once we get it all compiled. Dr. Lesser's lab is doing it today, so we're gonna just have one large data set. But I wanted to let you know that, as you are working through part 1 and part 2 of the lab report, the rubric for them, I've just kind of portioned it apart, and you could click on this part here, part 1, read it over, and begin your draft. These are articles that I think are like good places to get you started. So, I mean, you guys seem like you're seasoned researchers, so you could just pick an animal group like foxes, right? And if you wanted to find examples of biotic factors influencing foraging for that paragraph in your introduction, then maybe the one about coyotes, would be a good one to read. So you read it over. If there's an example of what coyotes are doing to reduce competition or to be more efficient, then you can build that in. There was one article.
So we have to choose a species?
No, it could be, you can pick any. You could throw in birds in there, you could throw in squirrels in there, you could throw in foxes. We're just looking for good examples, but those are ones that like I think are easy for students to like
So
know.
like if we pick like a bird, we would go for a bird for the whole time, right?
Not always. No, you don't have to. You could just find anything that's of relevance. You could say in coyotes, this is what we see for them reducing competition. In birds, like the warblers, in order for them to reduce competition, they partition the tree into different areas.
We're just giving some small examples
Exactly.
to introduce. Yeah.
Yeah. So your paragraph would probably start off with something like, biotic factors are known to influence how animals forage. And then your next sentence would be something like, for example, and there is actually an article about this. For example, red and gray foxes were found to have stomach contents that showed one of these species eats more plants while the other eats more rodents. And so they're eating different foods and not having to compete as much. If it was only one type of fox in the area, maybe they would eat everything. But because there's another competing type, they're changing their diet to avoid competing with each other. With predators, like if you were to type in predators and squirrel foraging or something like that into your search window, it may bring up say wolves and moose. I always go back to my research study group, right? Moose may, in times of vulnerability, so like from May to June, moose calves get born, and they're born in like a week and a half. The mums, there's still snow on the ground in Alaska, so the mums are trying to get food to those to be able to nurse their young. So they go to the areas where there is no snow, which is the wetland areas, okay? So those wetland areas warm up a little bit more quickly, and they go down there, and the mom moose will be eating the vegetation, while predators like bears emerge from their dens, and they have cued in evolutionarily, they have cued in to know, I need to go to the wetlands right now. And on their way, they're going to start getting their digestive tract ready to go, getting off of hibernation. They're going to start eating vegetation too, because they're omnivores. But then as soon as the moose calves are born, they are like raring to go. Their digestive tract is active again because they've been eating some of the veg. And now they're going to target those moose calves. Now, the moose calves are totally vulnerable. They're all lanky and gangly, and they fall over all the time. And so the mother moose, you might see in an effort to kind of save them, will oftentimes go into hiding cover a little bit more. So rather than being out in the open as often as they normally would have liked to be so that they can feed and get as much energy, they'll go and shift their habitat to avoid predators, okay? If there were no wolves at all or no bears at all, then maybe they would be out eating in the open, all the time. But because there's predators, they're shifting their behavior and making these like behavioral changes for feeding and energy. And then the same would be true about the snow and the rain. You'll have a paragraph on abiotic factors influence foraging. And then at that point, you can give the example of deep snow and deer or moose. It's hard for them. There's lots of articles that talk about them starving in the wintertime. Or canids, like our wolves, doing really well with dense ice pack. They're good foragers that way. You end your introduction more specifically with a reminder of the goals of the lab, and then you venture your hypotheses. In this case, and I'm going to send an email talking about all this stuff, but in this case, you're going to say things like, I think this particular simulation, say learning, is going to yield the highest number of calories, whereas having lots of predators and having harsh winter weather will yield the least calories, right? So your hypothesis is going to reflect which of those simulations that you guys supposedly do is going to give you the most calories on the chips that you've recovered, okay? Your methods will be, very straightforward. The lab manual for this particular section has like many you know, pages just devoted to what is different in each of these simulations. I think you guys probably read through that. You know, the optimal foraging simulation, the first trial, you go out, you set up your 10-meter square plot, you throw all the chips in the middle of the plot. They're different colors that have different calories. And you run out there, you have 1 minute. Each person runs out, takes 2 chips at a time, brings it back to their safe zone. And they don't know which of those chip colors has more calorie value. So they're just picking kind of randomly at that point. They might be more generalist, right? When they repeat that same trial at the very end, trial 8 or 9, they probably have learned that maybe the blue chips have more value than the other colors. And so they might change their habits so that they pick those more often, right? The next trial that we move into is predation. So in predation, it's tough, right? Times are tough when predators are around. And so you change your behavior. So the predators that we're gonna have are people with balls, okay? And you go out, you have your 1 minute to forage. You can take as many chips as you want, but if you get hit with a Nerf ball, you have to drop everything, count to 10, and then you can start all over again, okay? So you got to think about your strategy. Do you keep going back and forth to distract the predator and only grab a handful of chips at a time? Or do you like flip your shirt upside down to make a cup and grab tons of chips,
I have
right?
a question.
Yeah.
So for the hypothesis, we're not gonna explain it why we choose that, right?
No,
just
you're
gonna-
just going to say, this is what I think is going to happen. Yeah.
Yeah. And for the method, we just gonna describe it without explaining it.
Right. So the methods is sort of, I'm walking us through like the trials right now, and then you'll see a couple videos of the kids doing it yesterday. But yeah, the method starts off always. And again, when you look at the rubric, it'll be obvious to you, but it always starts off with when and where it happened. So this took place on such and such a day on Memorial Field. And then broadly, it's going to say something like, we set up a 10-meter square plot. We put, we have a safe zone 3 meters away. And then we took our chips and we randomly threw them in our feeding plot and began our simulations, right? So broadly, that's kind of what the survey looks like. And now I'm going to give you not cut and paste, because there's like 2 or 3 pages of these simulation details, but you can do it very succinctly. You can do it very like by saying, here's the optimal scenario. Everybody goes out for 1 minute, takes 2 chips at a time and brings it back to the safe zone. Okay, that's how you deal with your trial 1. So in one sentence, you can do that. Now, the next sentence on predators, instead of having my big paragraph from the lab manual, you can say something like, in the 1 minute, instead of seeking 2 chips at a time, we took 1 chip at a time, and predators, the balls, when we were hit, we had to drop everything, count to 10, and begin foraging all over again. Okay. The next one was winter weather. For winter weather, we like wrapped people's hands in tape. We all had gloves on this whole time too. So we had wrapped so now like your hand is immobilized and you're using like your non-writing hand and it's taped up and you're trying to pick up the chips with this hand that doesn't really work. Instead of going for 1 minute, you are reducing your time outside and active to 30 seconds, right? It's cold out, nobody wants to eat, and your hands are numb. It's hard for you to eat, right? So that was what we did with winter weather. Now competition, imagine there's 4 people in each of these groups, right? We have 4 plots that we spread out around the field. So if there's 4 people in a group, it's going to take 4 minutes pretty much for everybody to do the simulation, because everybody goes out for 1 minute each at a time, right? When we switch over to competition though, everybody goes out all at once onto the foraging arena, right? Because they're competing with each other for the chips. There's 2 simulations of competition. One is exploitative competition. They don't come in direct contact with each other, but they're taking everybody's food, right? So the others aren't going to have as much available to them. And so they ran out, they didn't touch each other. They brought, I think it was 1 chip at a time, back to their own little private safe site. At the end of that 1 minute, they counted how much they got. and then they, again, in between each of them, they brought all the chips and threw them back out so that the same amount was available at each time, okay? The contest or interference competition simulation, again, everybody goes out all at once for 1 minute, but this time you've got to stand over a chip and do rock, paper, scissors as if you were like a lion fighting for that food item, right? And whoever won would take it back. And if you didn't win, you would go find somebody else and do rock, paper, scissors, right? So you can imagine you're not going to eat as much during that trial, right? Because you're expending energy fighting and that sort of thing. The next trial, this is now second to last trial, is scavenging, okay? You go out for your 1 minute. You, I think, are taking 1 or 2 chips. You'll have to kind of look back on that. I think it was one chip at a time, maybe. Bringing it back to the safe zone, and somebody's going to sit next to your pile, and after 30 seconds of you feeding, they're going to start rolling a dice, okay? And if the dice lands on 4, they're going to take 4 of your chips away, like a scavenger would, right? Eating your food. Then they're going to wait 10 seconds. They're going to roll it again. Maybe they get a 2 this time. They're going to pull 2 away, right? So by the end of your 1 minute, even though you might have gotten a lot of chips that time, somebody has been eating them, okay? And then the final trial is repeating that first optimal trial, but now you have seen that maybe some of the chips, like as you're adding them up, you know, at the end of each of your trials, you'll probably realize that some of them give you more energy than others, right? And so you might go and pick some of those more often than not, okay? So the major part of your method section is going to be distilling down the simulation, right, into some brief, concise sentences, as opposed to all the details from the lab manual, right? You've got to give enough details so that somebody can recreate the experiment, but you don't need to be like bulleted, you know, you don't have to have all those bulleted details. Now, what gets tricky with the final part of the methods is the data analysis section. And that is because we aren't going to have done it yet, right? We won't do that until next week when this is supposed to be due. So what I'm going to encourage everybody in the email is just to be, you know, be pretty brief, and I'm going to give you some tips, right? You just say, we graphed mean calories per chip and mean calories per forager. We ran a chi-square test to evaluate if our observed chips were different from our expected number of chips. We ran an ANOVA to see if there was a difference in the mean calories per chip across trials, right? Something kind of brief like that. So you've like addressed that we're graphing some stuff, and we've addressed that we have done some statistics. And then you can embellish it once you've actually had that experience, like next week, you know. For your final paper. So that is I'm glad we had a chance to kind of go over that together before we jumped into you guys seeing the videos, because hopefully it'll be more clear now. But for the assignment for next week, there's that Dropbox for the part 1 of the lab report rough draft, and that's just to write, and it can be in the same Word document, a rough draft introduction, again, broad, optimal foraging stuff, specialist, generalist, paragraph on biotic factors influencing foraging, abiotic factors influencing foraging, goals, and hypothesis paragraph, right? And then you jump into the methods one, site description, when and where it happened, broadly, what did we do in the field, briefly, what did we do statistical wise, right, and graph wise, okay? So then just pop that into the Dropbox and we should be good to go. Good on the homework?
Yep.
Okay, and again, these articles, they're not the only ones, and they're probably older by this point. Again, you guys having done research before, if you go to the end to the bibliographies, those might lead you to other articles that are useful too, right? But you can give yourselves a shot at finding some cool stuff in the literature too. These are just some starting points for people with less experience. Okay.
Okay.
All right. So let's do this. Let's, if you can see this, can you guys see Amazon photos right now?
Yep.
Okay. Let me just kind of give you a sense of what it was that, I'm sorry, I survey roadkill. That's one of my research topics. So there's some dead stuff. This is a dead ring-necked pheasant, a dead, we had a fish day, my wildlife class. We went electrofishing. This is an invasive tench. This is the electroshocking boat with the booms, these long poles that have like the rods. This is also an invasive species. This is a rudd, but the students got a chance to shock. We got an eel.
Ooh.
This is a rock bass. This is a perch. And then we got, let me see if the eel, we got a bowfin. So yeah, we got a lot of cool things. I got a turtle one. Here's the eel.
Oh, I see.
It's quite long.
Yeah.
They're trying to conserve this species in Lake Champlain. Nature Conservancy actually has an American eel restoration effort going on. So it's one that they care about in the conservation community.
It's cool to see them. And then
Nice.
this is the perch.
That's a big one.
Yeah, he was giant. And this guy, the rock bass, it was a little bit light here. And then by the end of our day, it was dark. It blends, it has chromatophores in its skin. So it blended in
Wow.
with the color of the dock, which was pretty cool.
So it's just like a few hours and you can do
Yeah,
that.
not even, maybe an hour. Yeah. And then we went minnow trapping and got a whole bunch of these little minnows that have black spot disease, which is a parasite. That's not a good example, but so you see these little dots?
I see.
Those are
Yeah.
those are parasites. So we got a bunch of different minnows, which was kind of cool. And there were also some road-killed baby snapping turtles, unfortunately. But they're moving on to our research study, so that was kind of good to see. Anyways, all right, so let's watch a couple of these videos. You can see some of your classmates doing the activity. You can hear it okay?
Yep.
Yep.
Okay, so that's them setting up the plots and throwing out the chips that first time. So they've measured out 10 meters squared. And now they're distributing stuff supposedly randomly.
Mm-hmm. You will post this later, right?
Yeah, I'm gonna try and embed them into our Moodle site.
In a 10-meter square plot with a 3-meter safe zone.
Okay, so there's that one. And now this, I think, is optimal foraging. So now she's picking
2 chips at a
chips.
time, back to the safe zone, doing this for 1 minute. This is our optimal feeding bout. Chips are red, blue, and white of varying colors. She's got excellent strategy.
I was trying to cheer everybody on.
Yeah. It was like a caster.
It was a little hot yesterday.
Oh, I see.
Yeah, I can see the sun.
Yeah. 2 chips at a time.
Look at the turning and the pivoting. Excellent. Saving energy.
Good exercises.
Yes. This one is the predator. And these guys they meant business. Wait till you see this.
Simulating foraging with predators. Predators are the balls. This predator overshot his prey. He's going to get the balls.
I know that guy.
The prey is really capitalizing on this.
Serious. Look how many he's taking, right? He's taking advantage of him being a poor shot.
If they get hit by the predator.
I see.
Did you hear somebody yell, ow?
Yeah.
Oh my god.
Sorry, went hard.
Now this, yeah, here's
This
another
trial
predator.
has 3 predators.
So now there's 3 balls being used.
Trying our best to forage.
So imagine like pack hunting, right?
Mm-hmm.
You have a worse chance at eating something when there's a pack after you.
Drops everything, waits 10 seconds.
Yeah, that hit.
She dropped it with a lot of gusto, right?
Yeah.
Yep.
And then, so that's predation.
Competition, exploitative competition.
Exploitative competition.
Competing with each other for food on the same landscape, never coming in contact with one another. 1 minute, one chip at a time instead of a normal 2 chips. Bringing them back to their safe zone.
My volume went down. So they're all active at the same time, taking away their own food. Think you get a sense of that, right?
Right.
Yep.
And I don't know if it was this one. This might be rock, paper, scissors. This is contest competition.
This group is simulating interference for contest competition where they're fighting for a chip.
They must have dumped all their chips right there because they're not
Direct
moving.
contact competition.
Uh-huh. So they should have been moving, right?
They should be, yeah. The next group, I think I was like, this is probably not a good group to be watching.
Doing that as well.
Yeah.
These guys are moving around.
Oh, yep.
No. Yeah, that
They have-
should be it.
They have 3 people instead of. So I'll probably use this one as the example on Moodle.
True.
And it's the reason is, yeah, just the 3 people versus the 2. The other one was just recording it on the data sheet. Everyone, this is Rowan. Say hi, Rowan.
Hi.
Hello.
And then we have, maybe it was this one? Yeah, is this?
We are in a scavenging scenario. We've got our forager running around, foraging for these 2 chips.
But listen,
And at 30 seconds, the scavenger is rolling the dice and pulling away the number of food items that he rolls. But that will only happen at 30 seconds. And it will continue every 10 seconds, reducing our forager's cash.
There it goes again.
good with that
Oh,
one?
that's a low. That's a low roll.
Yeah, yeah. Now,
See that?
what was that?
Like he can see the roll on the dice.
Yeah, yeah. And she right now is doing,
We're simulating learning right now, learned behavior. Notice there are only
Okay.
and red chip.
Oh.
She's been wise in her selection on the landscape.
so that was the learning. Our final, we went out of order a little bit because I didn't want us to waste gloves. So you'll see here, at the very end, I taped everybody's glove up on that non-dominant hand. They all appreciated that. And now it's gonna simulate
Ooh.
running.
So we're simulating winter weather. It's hard to pick things up with your hands. 1 chip at a time, 30 seconds.
Yeah.
And it's making it look kind of easy. Should have taped it a little bit stronger.
Oh, he was using the wrong hand.
Oh yeah, that's why.
That explains it.
That's what we're talking about. Much harder.
Ooh.
Much hard, much
Just a one-handed.
hard.
And then he was actually honest and pulled a couple of them out because he was using the wrong hand there that first time. And I think we have one more video maybe of
We are simulating
she's doing it
winter
better.
weather, foraging when it's difficult. Our hands are cold. We're only going to be running around for 30 seconds instead of 1 minute using our hand that is numb. Ready? Set, go.
She actually does a good job, though.
Mm. You
Making
gotta
it
scoop
harder
it.
to forage.
Yeah, scooping up is actually a pretty good idea.
She is
Yeah.
doing pretty good. Other groups were getting grass.
Yeah,
Very fast.
yeah. I don't remember what was happening here. Oh, same thing.
Winter weather. Trickier. Tricky to forage.
Mm.
And so there were numbers on both sides of the chips. So when you look at the data sheet, there's like how many red chips, how many white chips, how many blue chips, and then how many calories were when you added both sides of them together, how many total calories of that
Yes, yes.
you had.
Okay. Yep.
You guys feel like you experienced it?
A
Yeah,
little
kind of
bit.
actually.
Yeah, good, good. I was
would want
hoping.
to do it.
Yeah.
Look,
Well,
it looks fun though.
you probably could do it. All you need is a set of poker chips. I got them on Amazon for I think $4. So
Yeah, but I don't want to do it on my own.
I know. Maybe you have is your family big enough that you guys could do it together? If you were
Yeah,
both.
I doubt it.
So yeah, any questions on that? I mean, I think, just reading through the overview page for this week's stuff, right? I'll embed these videos into this particular sheet right here on Moodle.
Mhm.
Once Mark Lesser's lab has lab today, and he gets me the data, I'll change the data set to hours. And for next week, just make sure you read part 2 of this lab manual section on the data analysis stuff. And I will, as soon as the Zoom is done, I'll bring it in and close caption it into YouTube and try and get it up there for the next day. So
Right.
yeah. I mean, you
I
guys,
need the closed caption.
yeah.
Mhm.
I don't know how good YouTube does it, but I always do it each time just in case. And I would say just, I'll make my screen as big as possible. I think you guys have used Excel, right? I mean, we're not doing
Yeah.
anything very tricky. We're doing like averages, standard
Yeah.
deviations,
Yeah, the basics.
and sums. Yeah, we're summing stuff up. So it should be straightforward. And the chi-square, have you worked with chi-square before? Have you guys?
Yep, we have.
I have.
So I basically, next to our table of raw data where we're doing like the mean calories per chip, mean calories per forager, for each of those simulations, next to it, I've broken apart the the chi-square test. So I have like a row that's the observed, a row that's the expected. The next row is O minus E. The next one is the O minus E squared. And then the last one just divides it by expected again. And then you sum it up on that last one. So then each of the columns, one's going to be for the red, the white, and the blue. So you basically just need to plug in your observed and your expecteds, and it auto calculates kind of for you. And you have your decision whether or not. The null hypothesis is we're evaluating optimal foraging. Are we foraging at random as the chips are found in the landscape, or are we foraging with a strategy optimally? And so the bag, one thing I didn't say, but I think the lab manual tells you, the ratio on the bag is that there should be 40 white chips, 20 blue chips, and 20 red chips. So you've got 25% chance on the 2 colors, and you've got a 50% chance of getting white each time you go out, right? If that was,
So that's the expected, right?
Yeah, that is your expected based on what's found on the landscape, if you were like just randomly foraging. But if we end up getting different ones, then it suggests that we probably foraged optimally, right? So we'll do a chi-square for each of them to see if one of the trials forced us to be more, strategic than some of the other ones. And then, I mean, one of the cool things about this is we actually we'll kind of look at predation generally, like we'll do the analysis, not saying how many balls each of the groups had. Then we break it out by balls. So there's one group that had just 3 balls. So 3 predators, like a big pack, versus 2 predators versus 1 predator. And you'll see the amount of energy on the calories coming in change significantly. So it's kind of cool to see that.
Okay.
But yeah, just be ready to kind of go through that that Zoom of me walking through the data. In the end, the students, you guys will leave with the Excel sheet already done, right? You'll leave with both of your graphs made, the chi-square done, the ANOVA done, and so you can just kind of move forward. And the next assignment is going to be to write up the results section, the discussion section, and the abstract. Okay, so this week is intro and methods. After our data analysis, the homework is to do the results, discussion, abstract. Okay?
Okay. I see.
Okay.
All right, so we'll plan on maybe not meeting. What do you think? You feeling maybe give that a shot? And then if we decide, you guys decide you need a meeting?
I'm good with
Yeah, I guess so,
watching the
yeah.
video.
Yeah. Check out the Zoom. If it's clear,
Yeah.
go for it. Again, I think what I usually end up doing is one of the tabs on the spreadsheet is the raw data and me working through it. The tab right beside it usually has it all completed. Okay, so
Okay.
you get a chance to kind of work on it, and then you'll have it there as backup, you know, with the formulas built in and stuff, just to kind of to check it out.
Mhm.
Okay.
Okay.
All right. Well, have a good rest of the week, you guys. Thank you for
Thank you.
You too.
bearing
Thank you
with
for
my
your help. Yeah.
Oh, you bet. I'll post those videos as soon as I can.
Yeah. That,
All right. Bye,
that's
guys.
okay. Yeah. Yeah. Thank you.
Thank you.
Yeah. Bye-bye.
Have a good day. Yeah.
Bye. Have a nice day.
You too.